Polar form. How to move to polar form. Complex number can transform into of polar form. The profile is like this. Z equals to polar form. Okay, polar form. Polar form. So polar form we have Z equals to R cos theta plus I sin theta. Okay, this polar form. So standard form. We have A plus B I. Similar here is I. Right. So how we get the polar form? How we transform the standard form to the polar form is come from the Pythagoras theorem. So we have this triangle. So since we have this triangle, so what we have actually is a triangle. It's angle here, and then this value is B, right? B, and then this value is A. Right. So we know that sin theta. Okay, sin theta is equals to B over R. R is R. R is hypotenuse. It is diameter. So now we need to know what is B here. So what is value of B? So from this formula, B is equals to R sin theta. And A, we can get A from cos theta. Cos theta is equals to A over R. Okay? So then if we find A, so A is equals to R cos theta. We know that B here is represented as this value, and then A is this value. So we just replace from the standard form to the trigonometry form. So A equals to R cos theta plus R sin theta. This is B, right? And then we have I here. So we call this form as a polar form. Remember here? So we also can represent this as a R theta bracket in the coordinates. So we also can define this, because once we know the theta, we know the hypotenuse here, we will get this point, the same point as we represented as AB. Meaning here, we can transform A plus BI to the polar form as a R cos theta plus R sin theta I. Okay. Here we can factorize R as if we factor R, we can have here R bracket cos theta plus R plus sin theta I. Right? The same thing. So next example, we have the definition here. So that we call as Z equals to R cos theta plus I sin theta. It's a similar form here. Right. Then, okay, here we have a standard form. So represent the following complex number in polar form, meaning we need to represent in form of cos theta and sin theta. So what should we find here is, we should find first is R. What is R? What is theta? If we find this R and theta, we can put into the polar form. So how we can get from, what should we do for the first step? First step we need to draw. Okay, first is to draw where is the point. So Z equals to negative 3 plus 4I. So what is negative 3 plus 4I in the diagram? So here we have 4I. Okay, we have 4I. We have 4I. And then here we will have negative 3. This is a real and this is imaginary point. So what we get is this point for the A. So the theta is from the x-axis here. So we transform into this first if we confuse. So what should we have? The trigonometry. So we have theta. And then we have a real number negative 3. And then we have this here is for I. So we have R here. So B, we have B. B equals to, okay, here we have B equals to sin theta, R sin theta. So if we do not remember, we just remember what is sin. Sin theta is equals to B over R. So B over R. Opposite, which is D is opposite. And the hypotenuse. Hypotenuse, right? So we do not remember all, but we remember the basic one. So it's more easier and not to be complicated and confused. So in mathematics, if we less remember, but we remember only the important part, so it's more easier. So what should we do? We need to have B. What is B, right? We need to find R, right? Because we have B. Here we have B. D is equals to B. So what is B? So B is equals to R sine theta. So R here, -3. Okay, R. We cannot find like this. So what should we do is, because we have two unknown. We have two unknown. We have B, but we do not have R. What is R and what is theta? So what should we do is we need to find R first. So how to find R? So to find R, we have this high. So R square is equals to 4 square plus -3 square. What we will have is 16 plus 9 square root. Okay, so square root. So we have square root 25. So square root 25 we have 5. So we have 5 here. So now we know that how to get theta. Theta is sine theta equals to B over R. So we have R, we have B, and then we can find theta. So theta is equals to R sine 4 over R over 5. So what we get? R sine shift, R sine fractions 4 over 5. 4 over 5, so what we get is 58.1301. 53 or 58 here? 53. 53.1301. Okay, we have this. So first of all, we need to check back what is our quadrant. First, the original quadrant is this. This second quadrant meaning how we just get this theta 1. For example, this is a theta 1. So this is theta 1. So this is theta 1, theta 1. So the exactly angle we need to find is this. So theta 2. How to get theta 2? Theta 2 is 180 minus theta 1. So what we'll have is minus 53.1301. So what we'll have is 126.8699. So now we have this degree, and we also have the R here. So we can form a polar form. So we know that polar form is Z equals to R cos theta plus sin theta I. So R is 5, so Z equals to R 5 cos theta, theta is 126.87 theta plus sin 126.87 theta. That's all. So we already managed to transform from a standard form from -3. We have -3z plus 4i. So it is similar. It is similar, but in a other form, in a polar form. It is similar. It is a similar number, right? So next is B. So first, what should we do? First, if we need to transform the polar form, is what should we do is first to draw. First is draw. Where? So how to draw? We just need this angle. Where is the angle? So square root 2 is a positive. This imaginary part is a negative. This is positive real number. From here is negative real number. So this is square root 2. So negative 1 is here. Negative 1 is here. So we get this. So the angle is here. Theta 1. So we need to get polar form, we need this theta. Theta 2. So first of all, we need to find R and theta 1. Okay, first. But how we make this problem more easy to solve? Okay, we transform this. Okay, make sure this the same. We transform in the same format, alright? theta, this is theta, so the opposite is 1. The opposite is should be 1, negative 1, okay. This is r, and then this is square root 2. So now we will have r. So how to find r? R square equals to negative 1 square plus square root 2 square. So we will have r equals to square root 1 plus 2. So square root 3, right? What is theta? So theta here, we get this first. Theta, okay, what we remember is sine theta is equals to b over r. So we have b. B is equal to negative 1. R is square root 2. Oh, r is square root 3. Square root 3. So we have here sine theta. So theta 1, this is theta 1, we call it as theta 1. So theta 1 is r sine negative 1 square root 3. So you put in the calculator. So shift r sine, so a fraction 1, and you get square root 3. Square root 3. You can eliminate first the negative. So what we have is 35.264. So what should you have? What should you have is, okay, what should we have to transfer to the polar form? We should remember this is z equals to r cos theta plus I sin theta. So we have r and then we have theta. So we just put r is square root 3 for the theta. Theta is some, you just get the theta 1, so we need the whole theta from the origin. So what should we do is 360 degree minus 35.264 degree. So what you will have, 360 minus 35.264. So what you will get, 324.736. So we can, so we get here, so what we get is, okay, r is square root 3 cos theta is 324.7 plus I sin 324.7 degree, right? So that is enough. We answer the question. 35. Now here the answer is wrong. Our answer is more accurate because we need to consider the angle from the origin as we do previous. Okay, next you see, you can do it yourself. You can try. So then you will get this answer. And then for the polar form and complex number. Okay, here is how to transform from the polar form into a standard form. So we have this. If we have this, okay, we have for example a, z equals to 2 cos 210 theta plus I sin 210 theta. Alright, so what we'll have is, okay, we know that in standard form we have a plus bi. So what should we do? We need to make this a standalone. Make this term as a this. So we should eliminate the bracket. So we need to times r here. So what you will have is, this is the idea. What we want, the final answer is, must be look like this. Right. So we have 2 cos 210 degree plus I square root 2 sin 210 theta. So here we can see that here this is a and then this is b. So a is equal to 2 cos 210 theta. So what we'll have is, put it in the calculator. So we will get negative square root 3. So b we have 2 sin 10. So we will have 2 times sin So now we have A and B, just put in the standard form. So put in the standard form we get, so standard form is A plus B, so Z is equals to negative 3 square root 3 plus negative 1 I. So equals to negative square root 3 minus I. Right? The same is here. Here is we need to so this constant should multiply this first and multiply this fourth, and we get A plus B I. The same that happen here is square root 3 should multiply all this, and then we need to find what is A and what is B. That's all. Right? So next is polar form of complex number. So if we have operation, we have two polar form. What should we have? What should we do? So if we have multiplications, we have two complex number, we multiply. So what will happen is, first is the R should be multiplied and this also, and the theta should be just added. If the division, we just need minus the theta. Right? So for example here, actually you can prove here. You can prove here. We can prove why we should minus, why we should add, and why we should minus. If we do separately, so how should we should we can do separately. Okay, we can do it like this to prove this theorem. To prove this theorem, what should we do is Z1, if we have Z1 equals to 1 plus I, Z2 we have 1 minus I. So if we have Z1 multiplied to Z2 is equals to R1, R2 cos theta 1 plus theta 2 plus I sin theta 1 plus theta 2. So what should we have? Okay, what should we have here? So first, we multiply this first. Z1, 1 plus I, 1 minus I. Okay, 1 plus I was minus I. We have 1, negative I, plus I, minus I square. We will get this. So 1, so we will have minus 1. So we will have 1 plus 1 is 2. So how to get this? How to get this is, we need to find R for each. Okay, for the first is 1 is 1 and 1. So 1 and 1 is here, so this is theta. So what should we have is R1 is equals to 1 square. This is 1. Then this is 1. So R square plus R square. Square root. So R1 is square root 2. Okay, for Z2 is, we have okay, positive real number 1 and then negative 1. So we have here is theta. So R2 we also have square root 1 square plus negative 1 square. So we will have square root 2, right? Square root 2. So now theta, what is theta? Theta here we should have sin theta is equals to 1 over square root 2. So theta is equals to R sin square root 2. So we will have, what we'll have, shift R fractions 1 over square root 2. Okay, what should we have? 45. So we have 45 degree. So here what happened is we should find this theta. So but for theta, this is for theta 2. But for theta 1, we can transform like this. We have negative 1 here, and then here is 1. So this is R, this is theta 1. So sin theta is equals to negative 1 over 1, right? Square root 2. Square root 2. So R sin, okay, theta is equals to R sin negative 1 square root 2. So we will have also 49 negative. So theta 2, so theta 2 is equal to 360 degree. Okay, we can see here 360 degree minus theta 1. 360 degree minus theta 1, okay? Minus theta 1. So we get theta 2. So it's theta 2, right? So minus 45. So what we'll have here 360 minus 45. 45. So we have 315. 315. We just put in this formula. So R1 is square root 2 up to square root 2. And cos theta plus. So we plus these two number. 45. Okay, 45. 45. Okay, this is theta 2. Let's say we set here is theta 3. This is theta 3. So this is theta 3. What we find here is theta 3. This is theta 1. Right? Theta 1. Theta 1. This is theta 3. Then this is theta 2. So now we need to find theta 1 plus theta 2. So 45 degree plus 15 degrees. So we will have 45 plus 315. 360 degree. So what happened here? What happened here? 360. So cos 360 plus I sin 360 degree. Right? So we squared, we got 2. Cos 360 we have 1. Okay, cos 360 we have 1. Okay, we have 1. Plus I sin 360 sin 360 bracket, we get 0. So what we get is 0 plus 2 plus 0I. So we will get 2. Is similar. Is how we prove this theorem. This also happened to Z1 over Z2. So you will get absolutely the same theorem of this formula. You will get the theta minus theta 2. Right? So next. Okay, next is polar form and complex number. This is also the exercise to you to try for the division and multiplication form. Okay, if you have this, you have to prove this theorem, right? Okay, next is exponential form. Okay, exponential form is in terms of e theta I. So here, what should you know here? You need to find, if you compare to standard form, z equals to a plus bi. For exponential form, we need to have e theta I equals to cos theta plus I sin theta. So, what is r? Because once we get theta, we need to have r. So, for z, we will get r is r e theta I. But theta I, okay. I put in a different number, different color here, different color. Okay, so z equals to r, and then e theta I. This is a exponential form in terms of this, where e theta I is equal to cos theta plus I sin theta. Okay, for example, if we have this, so first of all we need to draw. We need to draw, and then to find, where is, okay, if we have z equals to 3 plus 2i, where is 3 plus 2i? In the first quadrant? Yes, in the first quadrant here. There is 3, there is 2. So, there is theta. So now we need to find r. What is r? What is theta? Once we get r is theta, we just put in this formula. That's all. So, okay. So r is square root 3 square plus 2 square. So we get 9 plus 4. We get 13, square root 13, right? So here we get square root 13. Theta, what is theta? Theta is equals to, okay, we have sin theta. Sin theta is equals to 2 over r square root 3, 13. So theta is equals to r sin 2 over square root 13. So what we get as a theta? Okay, we put the calculator. Sin fractions 2 square root 13. Okay. Square root 13. 33.13. So we get 33.69 degree. So in this polar form, okay, in these definitions, okay, we have definition. So the argument of z should be in the radian. So how to find in the radian mode? Okay, how to find in the radian? So this is another part you need to know. Okay, this is another part you need to know. How to convert degree to radian. How to convert degree to radian. As we know, we just remember this one. Pi is equals to 180 degree. So now we have 300.69 degree. So what is x here? What is theta here? So what is theta here? What is theta in radian? Here. What is theta in radian? Okay. I put it as a x. X is theta r. Okay, in radian. So what is r? What should we do here? We put it as x. So multiply this to get x. Multiply this and divide by 180. So x is equals to 33.69 degree times pi over 180. So what we'll get is pi you can replace as 22 over 7. Okay. 33.69 divided by 180. Or you can just leave the pi. So we can just leave as a pi is we can just leave in the pi terms. Just like here, we have a pi term. We can multiply, but it's more nice. We can leave as a pi term. So what should the answer we will get is? So the answer we will get is 0.1872. Okay, we have 0.8172, right? And then we just put in the polar form. So we put into the exponential form. So we will get okay, what is r? So now what is r? We get r. Okay, here is our r. So we have r square root 13 and we have theta in 0.1. So we will get z equals to r e theta I, right? So r is square root 13. Theta is in radian, in the radian mode. Radian. So 0.182 pi, right? 0.882 pi I. That's all. This is the answer. Easy? Okay. And the similar step we need to do. First is draw, find the r, find the theta, and then convert to the radian. The similar is here. Alright. Next is standard form. Okay, how from the exponential form to the standard form? How to convert exponential form to the standard form? This we will continue later.